So sometimes we can simplify a calculation that involves complicated functions with products, quotients, or powers by taking logarithms. So for example, so I'd say sometimes we can simplify a more complicated expression or a more complicated calculation of derivatives, calculation of the derivative. I'm just rewording on the fly here what I had written down. Of functions that involve products, quotients, or powers. That involve products, quotients, or powers. By using logarithms. Right? So we're going to simplify. How are we going to simplify? By using logarithms. Okay, so we look at something and go, wow, wow, it's like really, you're going to be doing this, that, and the other, and all kinds of calculations and that, and you think, wait a sec, if I took the logarithm, then I can use the laws of logs to simplify things, right? Because we know that the log of a product is the sum of the individual logs. And when I say log, I mean log or I mean ln, right? Natural logarithm. We know the log of a quotient is the difference of the logs, and especially we know the log of a power is you can move the power in front, right? And then when you take the logarithm, I automatically do that. So if I'm taking log of both sides and I got like a 5 to the x, I'm just writing it as x log 5 or x ln 5 as soon as I take the log of both sides. Okay, so let's differentiate. Okay, so up until today, if I asked you to do that, you'd say, oh, great, well, I'm going to use the quotient rule, and I'm going to take the denominator, 2x plus 5 to the fourth. We're going to multiply that by the derivative of the numerator, which is going to involve the product rule and the chain rule and all of that. And then I've got to continue the quotient rule. But here's what we're going to do. We are going to, step one, if you're going to do logarithmic differentiation. So logarithmic differentiation. Step one. Take the natural log of both sides. Natural logarithm of both sides. Now this, at this point, or whenever this ends, you'll then be able to do the last question on the assignment, right? Which shouldn't take you all that long. So take the natural log of both sides of the equation y equals f of x. Well, y equals f of x with respect to x. Actually, no. Just take the natural log of both sides of y equals f. That's the next step. And use the laws of logs to simplify. Okay, so we're going to do that, right? We're just going to write it out. So the ln of y is equal to ln. And step one, solve it. Step two. There is no step two. So I'm writing natural log of both sides, and one little thing is that I change the square root to a 3x squared minus 1 to the power of a half, right? Because we're going to use that law, the law of logs, to simplify that power. Okay, and in this case, there's really nothing stopping us from doing it the other way, right? I mean, yeah, it's not like we have to do this. Okay, so that means that ln y is equal to, all right, so let's simplify that, right? It's going to be 5/2 ln x, right? So just that, taking the natural log of that, right? But when I take the natural log of something that has an exponent, I just kick the exponent out front, right? So it's 5/2 ln x. Plus, hey, it's got an exponent, so it's going to be 1/2 ln 3x squared minus 1. Minus, because that's division, right? 4 ln 2x plus 5. Okay, so let that sink in. You want to take a look at that and say, oh, okay, got it. Right? And if not, let me just pause this while it sinks in. And look, there really is an x there, which wasn't there a moment ago. Okay, so now so step 2 is to differentiate implicitly with respect to x. So 2, differentiate, this is where the respect to x comes in. Differentiate implicitly with respect to x, right? WRT. Differentiate implicitly with respect to x. Okay, so I'm going to kick to the next page. You're looking at it in front of you, right? So the ln of y is going to be 1 over y prime, right? So that's the derivative of the left side. Derivative of natural log is 1 over the whatever, right? And then in this case it's y, so it's y prime. Equals 5/2, right? That's just the ln of x is 1 over x. Okay, plus 1/2. And we've got, what have we got? We've got the ln of 3x squared minus 1, right? So we're going to end up with a 3x squared minus 1 down here. But it's chain rule, right? So then we also need the derivative of 3x squared minus 1, which is 6x, and that's going to end up here. Right? So I'm not going to write it as 1 over 3x squared minus 1 times 6x. I'm going to say, hey, we need this in the bottom, the 3x squared minus 1, but up top we need the derivative of 3x squared minus 1. Right? Which is a little bit easier than having a 1/2 3x squared minus 1 to the negative 1/2 times 6x and all of that good stuff, right? And then minus 4, right? So 4. Or 4 over 1, right? So we end up with and the ln of 2x plus 5, so we get a 2x plus 5 down here, and up top we get a 2, right? Because we do the derivative of 2x plus 5, we get 2. Okay? Right? Easy, huh? I mean, it's a heck of a lot easier than quotient rule and, you know, and all of that. Okay, so what's next? Well, so what is next? Then we solve for y prime. Right, so what's y prime equal to? Well, y prime is equal to y times, okay, because we got 1 over y times, and we'll just kind of clean these up, right? So what do we got? 5 over 2x plus the 2, that takes that to 3x over 3x squared minus 1 minus 8 over 2x plus 5. Okay. I'm not going to combine those into a single term. We're not going to go for a common denominator here and combine them in, you know, that's just, you know, but that's possible, right? But we don't want y in there, right? We want this in terms of x, but we know what y is. So we're just going to substitute. We know what y is. It's defined in the very first line, right? Y equals. So that's what we're going to throw in for here, right? We know what y is. So, y prime is equal to x to the 5 halves, the square root of 3x squared minus 1, over 2x plus 5 to the 4th, times 5 over 2x, plus 3x over 3x squared minus 1, minus 8 over 2x plus 5, and that's it. We're done. Okay. So, two things to keep in mind, right? Test coming up next week. Not all multiple choice questions are created equal, right? I mean, they're all worth a mark, and some of them, it's like 3 seconds worth of work, because it's really like, what's the root of 4x squared? And, you know, you kind of look at it and go, really? They're just asking me this, and that's worth it. The other one is, use the quotient rule with 4 applications of the chain rule and get this, right? So just keep in mind. You know, some of them, yes, they really are that easy. And now, written response questions that are worth 3 marks, no, they're not really that easy, right? I mean, so if you see a written response question worth 3 marks and solve it in 1 line, you're likely getting none of those 3 marks, okay? Because you messed up. We're not giving you 3 marks for doing nothing. So there's going to be multiple steps, right? Written response worth a mark is usually, well, you're doing something. Right, you're just showing me, like, find the derivative or determine the derivative, show me or state the derivative, but it's not asked as multiple choice, so you don't have choices, you're just actually doing a derivative and saying, here's the answer, right? Now, what if? Now, we know what the derivative of this is, right? But using log laws means we should be able to do this logarithmically, right? And we know what we should end up with because we know what this is. So let's just give it a try. So we say, well, ln y is equal to n ln x, right? Take the natural log of both sides, and when I do that, if there's a power, it's coming out front. And now we'll take the derivative, right? So it's going to be 1 over y prime, which is equal to n over x, right? I mean, the n is just a constant, so it's n times, and then ln x is 1 over x, right? So it's just n over x. So y prime is equal to y times n over x. But we know what y is, right? Okay, and then back to exponents and quotients, and this is going to be an n minus 1, so y prime will be n times x to the n minus 1. Totally not surprising, hopefully, because we already knew that that's what it was. But here it is using logs instead of using first principles, right? Okay, you got x to the n over 1, so you're subtracting exponent. That's an exponent of 1, so it's n minus 1. And then n times x to the n minus 1. All right, just, it's like, wait, 10 exponent laws, really? Exponent. Way back there. What if, and actually I think I'm doing one of the questions in the assignment for you, but what the heck. This is pretty much the explanation. Y equals x to the root x. Now here, you don't have much choice, right? We have no way to do this question without using logs, right? Because we've got that exponent, and an exponent's not a power, it's not a number, it's not x to the 5th, right? It's x to the root x. So we have to do this logarithmically. So you take the natural log of both sides, and while you're doing that, of course, you move the power out front, right? And then you take the derivative. So we get 1 over y prime is equal to, and this is product, right? There's a product there. So it's root x, let's just call that x to the half. Okay, so it's the first term times the derivative of the second term. Derivative of ln x is 1 over x. Plus And then it's the second term, right? So ln x, which for some reason I don't want to write the x, times the derivative of the first term. So remember, the first term is x to the half. So that derivative is 1/2 x to the negative a half. Okay, and now, we can do a little bit of cleanup. And, one of the big things to keep in mind, especially with multiple choice stuff is like, maybe I have the right answers, just not in the same form. So always be looking in multiple choice, like do a couple of lines, look at the answers, and you're kind of asking yourself two questions. Number one, do I have the answer so I can stop now? And number two is, if I don't, then what form are they in, right? They shouldn't be in like 4 different forms. They should all sort of be in the same form. It's like, well, it looks like everything is factored out and I've just got this, so that's what I'm aiming for as I'm doing my solution, right? Or, everything is like in this last one. This last one here, right? Like, stuff's written like this. Okay, it means I'm not having to combine these, get a common denominator, right? That would just be a pain, like really. Okay, but maybe it has one denominator, and you say, great, now I have to combine these. I have to get a common denominator, multiply it, and that's a question that you say, I'm going to leave that for later, right? Because it's just a lot of work. Okay, so where is we? So y prime is equal to y times, okay, now we can do a little simplification, right? We got x to the half over x, so that's 1/2 minus 1 is negative a half. So this will be x to the negative a half plus, and what do we got? Ln x over 2 times x to the negative a half. So at this point we could say, hey, the x's, they're common, I could factor that out, right? Or we could say, well, here's what I'm going to do. So I know that y is x to the root x. This will be 1 over root x plus ln x over 2 root x. Okay, so I can get a pretty nice common denominator here, right, which is 2 root x. So let's do that. X root x. So this will be 2 over 2 root x. So we'll get 2 plus ln x over 2 root x. Right? And let's just say we leave it like that. Now, how else might you see it? Well, it could be a root x factored out. This could be an x to the negative a half. This could be written as root x minus a half, right? If that root x came out there as x to the negative 1/2, okay, then you have powers with the same base.
How do you know to leave that long?
You do this on a written response. I'm probably pretty good with it, right? If it's multiple choice, again, what you're doing at some point is you're starting to look like probably you don't have much choice here, right? I mean, this is this, right? That's all you can do. There's nothing else you can do there. At that point, you then start to look and say, okay, what form is the answer in? Because that's going to guide you as to, okay, what am I going to do? If you see the answer is kind of in this form, then you know what, I'm leaving that in there. If you see the answer is, because at this point, you've got, you kind of look at these two and you should be thinking, I've got an x to the negative half here, and I got an x to the negative half here. So does the answer have that factored out? If it does, then I'm going to want to factor it out. If it doesn't, then I'm going to want to leave it there. Okay, so there is a bit of a.
Will we ever have 2 answers that are
no
correct?
Hopefully, well, I'm not going to say no, but hopefully not. Okay, so there should never be 2 correct answers just in different forms, right? Unless something said like fully factored and whatever, and one of them wasn't, in which case, then it's legit, right? You said, but it's equal to that, yeah, but that's not factored. Oh, right, okay. All right, so there would need to be some distinguishing characteristic. Okay, so same deal here, right? Nothing we can do with this. You can't just sort of say, hey, it's e to the x times x to the e to the x minus. That doesn't work, right? Works with numbers, doesn't work with. So we are taking natural log of both sides and pulling the power out front, as we are wont to do, right? Which is the whole reason we do this log stuff, right? Just to get powers out. And ln y is 1 over y. And then we've got product law, right? So it's going to be e to the x, first term, right? Times the derivative of ln x, which is 1 over x, right? Remember, you got your formula, keep the formula sheet handy. Right? You want to be using it today and every day, and then on the test we'll probably, we give you a different one? Yeah, okay, right, I think. Because we're probably going to write our test down in the other room, in 305, right? I will text you to let you know for sure, but it's likely we're going to do that, so. Because it's got formula sheets and desks which are already set up for a test, so, you know, it just makes sense. And then what do we have? We have ln x times the derivative of e to the x, which is e to the x. Right. That's plus. See? That's why you guys are here. I keep doing that. I think, you know what, it's probably on here. I wrote it times and I changed it to a plus. I really should look at this stuff. That's why I write it down. Plus ln x times e to the x times 1, right? And that. Right down. So, what have we got? Well, y prime is equal to, so we know what this is, right? So it's x e to the x. Wait, you could write that a little better. Bracket, and we've got e to the x over x plus e to the x ln x.
Did you write that as e to the x over x?
Each, right, which?
Like plus e to the x over x.
No, we've already done the derivative. So
Oh.
this is part of the derivative. This was the derivative of ln x, right? So product law, it's this times the derivative of that. So that's e to the x 1 over x plus ln x times the derivative of this, which just is e to the x. Okay. And then what I'll do is we'll do this and we'll give a few alternate answer forms, right? So let's say we take out the e to the x. So we will have e to the x times x to the e to the x. So I've taken out the e to the x, so this will be 1 over x plus, and I took that out, so ln x. Okay, so there's one where it is factored out, right? And again, multiple choice, what are you looking at? You got to look at the forms of the answers, right? You got to say what form, you know, what form are they giving this to me? So what's an alternative? Well, alternatively, or alternatives, right? So you get this, and you look at the multiple choice answers, and you say, well, for some reason, they've got a 1 over x out front, right? They put an x out front. So they wrote y prime equals e to the x times x e to the x times 1 over x. At which point, I say, well, okay, I got to factor that out. So this is going to be a 1, and this is going to be an x ln x, right? So it'll be like, but we can write that as x ln x plus 1. So I flipped them around, but okay. So what's 1 over x times x ln x? Where the x's cancel, you're just left with ln x, and 1 over x times 1 is 1, right? So you could do it. You could look at the answer that's given, and you could say, okay, I've got this. If I multiply 1 over x times this, I'm going to get ln x, check, and I'm going to get 1 over x, check, and you say, okay, then I know that my answer is equivalent to this, and that's the one I'm going to circle, right? And then I'm going to move on. What else could they do? Well, they could say, hey, look, these bases are the same, right? Yeah, so y prime is equal to, right? So we got an x minus 1, so we got e to the x times x e to the x minus 1, right? That's combining these two guys. Bases are both x. This is e to the x, this is minus 1, right? You're dividing, so you subtract 1 from the exponent. Times 1 plus x ln x, just to flip these around again. All right, so any of them, right, they're all equivalent. they will not all be there as answers, right? Only one of the three of those answers would appear as a multiple choice answer. Okay? And so you need to be kind of looking at, you know, you can just do it and say, well, this is what I've got. Now, what's that equivalent to? You know, what am I looking at down there? More? Should we keep going? Let's do one more. Yeah. All right, let's throw a little trig in, right? Needs practice with some trig. So y is equal to tan x to the 1 over x. So, well, we've got a power in the exponent, right? So I need to use logarithmic differentiation. Okay, so we take the natural log of both sides, and we get ln y is equal to, and we bring the power down, 1 over x, the natural log of tan x. And then we keep going, right? So 1 over y. Oh, my advice for written response. I always used to do this for diplomas, but we don't write on diplomas anymore. But don't erase unless you replace. Okay, so here's the idea, right? Like you're doing the test, you've got a written response thing, you've written it all out, you think that it's all garbage, like this is total, you know, and then you erase it all. So how many marks will it get if it's erased? 0, right? I can't give it anything. If you leave it there, it may still get 0 marks, but who knows? You might have just been, you know, like this far away from the answer, just didn't realize it, and you're getting 2.5 out of 3. It's like, hey, you know, all you had to do was subtract this x1 from this here, and there's the answer, right? So you're a half a mark away from the answer, and you don't realize it. So don't erase stuff, okay? Unless you're planning to replace it. So you just go and you're looking at it, you're saying, yeah, I don't think this is it. I'm clearing it off. I still have 20 minutes. I'm going to try again. Okay, so don't erase unless you replace. Don't leave multiple choice answers blank. Fill something in. Okay. You'll get any marks for. All right, what do we got here? So we've got 1 over x times 1 over tan x. Okay, so we've got this times the derivative of ln tan x. So derivative of ln is 1 over tan x times the derivative of tan x, which is secant squared x, plus, and now we do the ln tan x. Ln tan x times the derivative of 1 over x. So 1 over x, which is x to the negative 1, and the derivative is negative 1 over x squared, right? It's so derivative, whatever. Y equals that, then y prime is negative x. So negative 1 over x squared. Right? But it's not minus, it's times, so we'll throw some brackets around there to say, hey, you're multiplying now. Okay, so now what? Whoops, too far. So y prime is equal to, so y, right, which we know from above, which is tan x to the 1 over x. Okay, so instead of writing y prime is equal to y times something, I'm just replacing this, right? That's y. That's this. That's good. And what have we got? We got sec squared x over x tan x minus ln tan x over x squared. Okay? And maybe that's the answer. And maybe it isn't. So what if the answer was this? Throw an x down there. So cosecant x secant x. Yeah. Okay, so those are equivalent. Right now. Oh, yeah. Those are equivalent. So here's what happened. An x came out of the denominator and ended up out here, right? So that x. So there's no x underneath here. This x squared has become an x. So apparently secant squared over tan is cosecant secant. Right? Secant squared over, so I'm going to argue that secant squared over tan is cosecant secant, and you can puzzle that through until you figure out that, yeah, it is. Okay. Just remember, secant squared is 1 over cos squared, and divided by tan, so that would be times, and you're going to flip sine over cos, so it'll be cos over sine, so you've got cos over sine times cos squared, and cos is going to cancel with the cos squared. You got 1 over cos x sine x, which is secant cosecant. Okay. So they're the same, right? And so you're getting this, and you're seeing this as an answer along with 4 other things, right? You got stuff like cos x, cotan x, or some weird stuff in here, right? And you got to figure out what's this. You know, like I can see that I've got everything, but so you know, what's this turn into? Because I've got 4 different answers, and they all just sort of differ. Your other big question is, where do the answers differ? You know, like if they all have this, then you're not worried about how did I get that. That obviously is correct. If they all have this, then you're just saying, what's the distinguishing factor? Well, there's 4 different variations of this. So which of them is equal to this? Okay, that's what you're asked, right? Like when they give you a sinusoidal equation and they all start with 2, and they all end with plus 12, you're not really worried about the vertical stretch or the amplitude and the vertical displacement. You know they're 2 and 12, or they got the question totally wrong. You're interested in, well, what's the period and what's the phase shift, because those are the only distinguishing factors between these 4 answers, right? So that's what you're doing. Okay, one more, or you just want to go?
Let's do one more.
One more? All right. We can do more after the one more. Okay, this one's actually, I kind of like this one in a sense. It's
Visually stimulating.
given fx equals pi squared in honor of Friday, plus 2x. Sorry, 2 to the x, 2 to the x, plus x squared, plus x to the 1 over x. Okay, given that, determine the slope of the line perpendicular to the graph of f z. Okay, so we've got this function. We want the slope of the line perpendicular to that function at the point where x equals 1. Okay, just the slope, right? Not the equation of the line, right? Which means, well, if we find f prime of x, then we've got the slope of the tangent line, and if we want the perpendicular, it's going to take the negative reciprocal of that, right? So be careful what it's asking for. You don't want to go and figure out the equation of the line, because now you're throwing a 1 in there and getting a point, right? You get an x, y, and that's just going to be like a really ugly kind of point. And then you're doing, like a lot more work, and at that point, at some point, 5 minutes later, you realize, oh crap, you only wanted the slope, right? And I worked out the equation. So read the questions carefully, right? Make sure you're answering what they ask, especially in this class. It's not going to kill you so much in a Math 10 class, like, oh, I went too far. But too far in a Math 10 class, like, I went another line. Too far in this is like, I went another page, right? Like, and I did a whole ton of work, and it took me 10 minutes, right? And you don't want to spend that. Okay, so here's the deal. This is a sum or difference, right? The derivative of this is easy. It's what? 0, because it's constant. Right? Derivative of this is on your formula sheet, right? Derivative of b to the x is b to the x ln b. So you could do it using logarithm, but really, okay. And again, that's being smart, right? You're saying, hey, I think that's on the formula sheet, right? I got this b to the x, so I don't need to do a logarithmic differentiation on this, because I'm going to end up with what the formula sheet says I'm going to end up with. That's 2x. So this is the only thing, right? So what we're going to do is we are going to differentiate this separately, right? We're going to find the derivative of this. Okay, we'll do that now. And then we'll do the derivative of the whole thing, sticking whatever we get for this in on the end, right, plus that expression. And then we'll have the slope of the line, right? And then we'll stick a 1 in, and we'll figure out what the slope is at 1, and then we'll take its negative reciprocal, and then we'll be done. So that's the plan. So the plan is this. And you should put some explanation. If this is what you're going to do, put an explanation, right? I mean, you could certainly have written, what could you certainly have written? You could certainly have written ln y is equal to 2 ln pi plus x ln 2 plus 2 ln x plus 1 over x ln x, and done them all that way. But we're saying no. So look, we only need to use logarithmic differentiation on x to the 1 over x. Okay? So now we're just going to do that. Okay? And then we're going to come back and say, but make some mention of that, right? So people know what you're doing. That people being me, the guy's marker. So I'm not looking at it going, huh? Okay, like what did they do? What's going on here? Okay, so we are going to do this. Y equals x to the 1 over x. Ln y is 1 over x ln x. So ln y is ln x over x. And now we're going to differentiate that. So 1 over y prime is equal to x times the derivative of ln x, which is 1 over x, minus ln x times the derivative of x, which is 1, over x squared. Okay, which is, actually, no, I'm not going to do that. I will extend the page. So let's y prime is equal to y times, so let's do, what do we got? 1 minus ln x. Let's start in the right place if you're going to draw that. Okay, but y is x to the 1 over x. Okay, so that's good. So we need this, right? So how do I select it? Take this, go. There you go. Come on. I want that. I want this. Whatever. Control C. Okay, I'm going to go to the next page because we're going to need that, right? All right, so what are we doing? So the original function was f of x is equal to pi squared plus 2 to the x plus x squared plus x to the 1 over x. So f prime of x is equal to 0, right? Derivative of pi squared, constant. 0. Plus 2 to the x ln 2. Okay, so on your formula sheet, right? The derivative of b to the x is b to the x ln b. No, what's derivative of? Yeah, b to the x ln b, right? Yes, b to the x ln b. Plus 2x. Plus, okay, can I paste this in? I can. Can I move this over? Okay, hang on. Clean that off. Plus, I don't know. There, huh? Learn new stuff every day. We're the smart part. Okay, plus the derivative of x to the 1 over x, right, which we worked out separately. Okay, and now we're bringing it in. Okay, and great. So what's that work out to? 2 to the x ln 2 plus 2x plus x to the 1 over x. And we want f prime at 1, right? We want the slope of the tangent line when x equals 1. So 2 to the 1 ln 2 plus 2 times 1 plus 1 to the 1 over 1, 1 minus ln 1 over 1 squared. Okay, so 2 to the 1 is 2. Ln 2 is ln 2 plus 2 plus, okay, that's 1. That's 1 minus, that's 0, right? Ln 1. Anything to the 0 is 1. So that's what, this is just 1, right? This is 1 minus 0 over 1 times 1. Plus 1. Okay, so what do we got? Let's move this up here. So we'll get 3 plus ln 2 squared, which is 3 plus ln 4, right?
Oh, you could bring the exponent back up.
Okay, so if they come down, they can go back up. The slope perpendicular is the negative reciprocal of that, so it's just negative 1 over 3 plus ln 4. And then now we're done, right? We got the perpendicular slope. Okay, so now you have the tools to finish the, the assignment, right? You may hand that in with 2 names on it. You only need 1 copy if there are 2 names on it. Hand it any time between today and tomorrow, so you can hand it in now or later today or tomorrow. Tomorrow we start, I'm going to give you the outline for the next unit, because we're going to start that.